So last class we talked about binomial distributions, and that's like the probability that you roll a pair of dice 6 times and you get doubles. All right. That would be a situation where you have a binomial distribution. Now today you're going to notice a little difference in the way that the question's being asked when you're looking at a geometric distribution. And you'll notice that it doesn't give you a set number of trials. It's until you get whatever solution you're looking for. So if you roll a pair of dice until you get doubles, or you attempt a 3-point shot until you make it, or you keep placing a $1 bet and the number 15 until you win. And so there's a little difference in the way that you're questioning. You're not giving a set number of trials. That's called a geometric distribution, and you can calculate the probability of that as well. And so, as you know, a binary distribution, you're looking at bins because you have a set number. Well, now we're looking at bits, where we're not going to have a set number of trials, but it does still need to be independent of each other. They do still need to give you the probability of success. And of course, it's binary, so you're looking at success versus failure. So an example setting of this is like the lucky day game. So if I said, I'm thinking of somebody, and I want you to guess what day of the week the person was born on. And if you get it correctly, you win. If you guess it incorrectly, you lose. And so the probability of guessing correct, because there's 7 days of the week, is 1 out of 7. So I don't want to know the date. I just want to know, were they born on a Monday or a Tuesday, right? All right. So we will call this a geometric random variable because the possible values are 1 through 7, and that's how we know it's a distribution. Okay, so we're going to check bits. You are either going to guess the day correctly or not. It is independent because every time I'm going to select a different person. So everybody's got a chance to guess, but anytime somebody guesses, I'm going to select a different person in my mind that might or might not have been born on a different day of the week. T would be until you guess correctly, and S is the percent of success, which is 1 out of 7. So 6 out of 7 is failure. And again, just like a binomial, we're going to use the same distribution. You go to second vars, and that'll be where you see the distribution. You got to scroll down even farther. Because this is a geometric setting, you would select Geomet, PDF, and it's the same situation that we did with binom. PDF is when it's equal to the number of trials. You use CDF when you have the less than or greater than sign, and if you have a greater than sign, you have to take it one away from 1. All right, so let's try our situation in these situations. Anyway, so for the first one, you're going to use this one here. So you would use Geomet, PDF, and again, the trials is 1 out of 7. 7, and the K value is 1. So go ahead and type that in your calculator. Man, you got to scroll down far to find it. Okay, PDF 171, enter, and you should get 0.143. So it's about 14.3% chance. Then you can go back and do it again. This time you're going to see the probability of 2 trials to get the right answer. PDF again, so it's 1 out of 7, but this time it's 2. Enter, and you should get, so it's the same thing here, 1 out of 7, comma 2. And that equals a little less, 0.1224. So it's about 12%. Probability of 3. Same thing. I wonder if it's going to be higher or lower. If you scroll up, you can actually do it faster. Just saying. And so this would be the same thing. 1 out of 7. I don't know why I keep writing it 2. 1 out of 7, 3, and that equals 10 point. Points. I was turning it into a percent for you. 0.105, so about a 10.5% chance. And so to find for any value, that would be the answer here in this particular game. Obviously, the probability will change depending on the game you're playing. excuse me, if you want to do it longhand, we call this Q. So it would be Q to the K minus 1 times the probability. That's another way to do it. But it's easier to me just to use my calculator and go into a distribution. So we want to find the probability that the class receives 10 homework problems as a result of playing the Lucky Day game. So we want to find the probability of y less than 10 and interpret this value in context. And so we know that it's a 1 in 7 chance. That's our probability. So this would be Geomet CDF, and it's the less than sign, so I don't have to worry about subtracting from 1. 1 out of 7, and the number is 10. So let's second bars, enter. The p-value is 1 out of 7, and that's because the lucky day determines if you're going to have, and so the answer is 0.786. So there's a 78% chance that the class is going to receive 10 homework problems as a result of playing the game. So this would be a situation where we said, if you guess correctly, I won't give you any homework. But if you guess incorrectly, you will get homework problems based on the number of incorrect guesses. Now let's look at this question. It says, how many times would you expect to play? So how many times, this key word right here, the word expect, should be telling you to find the mean. So that should come to mind. And so what the mean is the inverse of the probability. So we know the probability is 1 in 7. So we're going to put that over 1, and that actually equals 7 over 1. It's the inverse. So we would expect, if you're going to play the lucky day game, that it would take 7 guesses to guess correctly. Or 7 trials, I guess. And so this is just a fancy way of showing that the expected number of trials to get the first success is just the reciprocal of the probability. You flip the probability, basically. So let's look at an example. It says, to start my lawnmower, I have to pull a cord. There's a 20% chance that each time I pull the cord, the mower will start. So what's the probability that it would take exactly? So the key word is exactly. 3 pulls to start the mower. So I'm going to say it's Geomet. And the reason is because it says it will take 3 pulls. It doesn't say that I am going to pull the lawnmower a total of 10 times. What's the probability that 3 pulls will, doesn't give us the total amount. We're going to stop pulling the mower after we have started it. So that's a geometric distribution. So Geomet, and this is PDF because it's exactly 3. And you're going to put in 20%. You can type it in as a decimal or a fraction, it doesn't matter. And 3 is your number of trials. So let's go ahead. Make sure, again, that your calculator is in radians and not degrees, because my geometry class is changing to degrees now because we're doing trig. So make sure you've got that correct. And you should have gotten about 0.128, which is approximately 13%. So 13% of the time you'll start the mower with 3 pulls. How many times would you expect to pull the cord to start the mower? Well, this is 0.20, and we're going to put it over 1. So in your calculator, you can just do 1 divided by 0.2, which equals 5. And the reason is because 1 over 5 is equal to 0.2, and so, shoop, you flip that, find the reciprocal. So you would expect 5 pulls to start the lawnmower. All right, find the probability that it takes more than 10 pulls. So we're looking at more than, so the probability of x greater than 10. And if you think about like a distribution curve, if here's 10 and you want this part, then you have to take 1 away from it, because remember, a distribution curve always gives you the less than value. So the probability of more than 10 would be 1 minus Geomet, what did I say, CDF of 0.2, comma, 10. So let's go 1, oops, clear. 1 minus, second CDF, the p-value is 0.2, and the x value is 10. Hit enter, and you get approximately 0.1074. Awesome. Now I've got one that you can try on your own. Pause the video, and when you come back, you can see if you type stuff in your calculator correctly. Again, don't forget to go to mode and change to radians. All right, hopefully we'll get all these right. Come on back. So if we're looking at dice, you ought to know that there are 36 total outcomes when you roll a pair of dice. And the probability of getting doubles, well, that can occur 6 out of the 36 times, and I have them listed here. So that's the probability of getting doubles is 1 out of 6 if you simplify this fraction. So then we want the probability of getting doubles in exactly 3 rolls. So we just type that in our calculator using PDF because it's exact. And you came up with about 11.6% of a chance. And then this is interesting. If you've ever played Monopoly and you go to jail, you can get out of jail by rolling the dice and getting doubles within 3 turns. Otherwise, you have to wait until your next turn. And so that actually happens about half the time. So that's why most people don't have to stay in jail too long in the game. So at this point, you're going to work on the odd number problems as a class if you want to join us. Otherwise, you're going to do the even number problems. So this is 6.3. Let me see, 5 problem. So at this point, 6.3 exercises. I think it's geometric starts at 95. So you're going to do numbers 95 through 107. Tomorrow I will not be here. You will have review exercises, and then on Friday you'll be able to review some more. You've got plenty of sample problems, and I will post answers on the computer in Canvas. Thanks for watching, and good luck.